for joining. I'm here to give you a brief overview of the Panopta monitoring platform. We'll start with a quick architectural overview, and then after that, we'll move into a live demo of the platform. As shown in the diagram here, Panopta is deployed as a SaaS delivered solution. All of the main processing, data collection, and management happens in the cloud. What you do is deploy a series of agents and probes to collect data and send it back to our platform for processing, trending, and reporting. One of the vantage points that we provide in the platform is our network of public monitoring probes, which are running outside of your environment, allowing you to check any of your internet-facing services for overall availability, network jitter, packet loss, and latency. In addition to those metrics, we're giving you the ability to check any of your external applications for full end-to-end functionality. So beyond uptime, making sure that user workflows are working for things like logins, application usage, e-commerce transactions, as well as any other network-based services that you rely upon. In addition to the public monitoring probes, internally on your internal network, there is an on-site virtual collector, which is a virtual appliance. This virtual appliance brings that same functionality that we talked about on the public side of things onto your internal network. So you have the same application synthetic monitoring capability here. In addition to that, it monitors your network devices, your routers, your switches, your firewalls, and wireless access points for overall performance and availability as well. Second to that, it also does network configuration management. So for that same fleet of network devices, you have the ability to automate things like backups as well as your config management for those devices. The on-site collector can connect to your compute environment to gather data about your VMware workloads, whether it be the ESXi host nodes, the virtual machine guests, or the data stores. Beyond the VMware integration, there's also an agent that runs on the virtual machines, and those agents will gather various sources of data at the hardware level, at the system level, and at the application level, no matter what operating system and platform you're running, whether it be Windows, Linux, or Unix, and all flavors of databases, application servers, web servers, and off-the-shelf technologies can be monitored using our built-in plugins. The agent also enables and empowers part of our industry-leading technology, which is called countermeasures. Countermeasures are automated actions that allow you to respond to incidents with automated diagnostics as well as remediation runbooks. I'll show some of this in the demo itself. The top box here is showing a cloud workload, whether it be in Microsoft Azure, Amazon AWS, or Google Cloud, or other cloud providers beyond those three. We have full native functionality for monitoring infrastructure as a service workloads and platform services, as well as any cloud native functionality that's running in Kubernetes and Docker workloads as well. So whether your infrastructure is on-prem, in a private cloud, or in the public cloud, Panopta has the ability to monitor it for you. Let's move into the cloud-based console demo. What we're seeing on the screen now is the main management console for Panopta. You can access it from anywhere with any modern browser. In addition to this console, we have a mobile app that allows you to see some of the rich information that we're seeing here on the go from your Android or iOS smartphone device, in addition to being able to collaborate with your team members on active incidents that are occurring. Once you log into the console here, there are any number of default views and dashboards that you may be presented with depending on what your preferences are. The one shown on the screen here is something that we call our infrastructure heat map. It's representing all of the nodes in your environment, whether it's a physical network device, a server, a virtual machine, or an application or service in the cloud. Green, of course, is healthy. Red or yellow means there's an active critical or warning level incident. You can cluster and organize these nodes by whatever dimension or segmentation that works for you, whether it be by physical site or location, the type of instance that it is, or the tags that are coming in from our cloud environment so that you can easily use those same tags for your organization and your monitoring platform. Topology is captured here, so we can tag things with functional use cases and then be able to drill down and see what specific part of the infrastructure may be impacted with an incident or an outage. You're able to interact with these nodes by hovering over the boxes to be able to see what this incident is actually about and the related performance data that we're tracking for you in real time. In addition to these views, our incident management, it's a critical part of the Panopta platform. No matter where you are in the application, In the upper right-hand corner, you'll always see this bell that allows you to see your active incidents which are occurring right now. Each one of these incidents shows you the device or server or application impacted and the services within them that are currently having an active problem. From here, we can see the severity, the timing, and directly from this pane, having the ability to take certain actions, whether it be assigning this incident to someone in my team to become the lead, acknowledging this incident so that I can comment and log, as well as influence the alerting that will be sent out subsequent to this problem. In addition, being able to put this note under maintenance or look at some of the automated diagnostics that are being run for us in the background via our countermeasure functionality. As I drill into a specific incident, what we'll see is a one window view into all the data we're capturing. Along the top, we're seeing status and severity. We're seeing the timing attached to this incident and various actions that we can invoke to respond and react to this incident. Next to that, we're seeing problem and solution management so that our team over time can document the problems, what diagnostics are running, what actions are working and what actions are not working. And over time, start building up a solution library that allows us to document well-defined playbooks within the system that can be used for subsequent incidents just like this one so that our team can resolve those problems even faster. Right below that, we're seeing an event band that's collapsible for each unique problem that's being merged together into this incident. We're seeing the metric or service that's impacted, the reason or threshold breach description here right next to that, and then the historical performance trend before the incident, during the incident, and after the incident shown end to end. To the right, we're getting some details around historical patterns around availability, the last time an incident like this occurred, as well as over the last 90 days, what's been the recurrence pattern. On the second half of the page, we're seeing other performance-related metrics that may be causing the problem that we're seeing. So easy ways to correlate what's happening at the system level, the network level, at the application level, with easy filters here to look at things by category and time frame, as well as a customizable dashboard to move these metrics around and reorder them as needed. Another piece of functionality that'll help us here is the countermeasure functions. As we can see here, when this incident occurred, the system launched various actions on our behalf to take many of our diagnostic actions and automate them for us. In this case, we saw it run a top process capture, a netstat capture. We had it pull in various logs, as well as running certain custom actions to test upload and download speed and application health. These are all examples of incident enrichment-based actions so that we can understand root cause more effectively. But we can also use countermeasures to resolve problems that we're having using remediation runbooks that we may have defined in scripts. The system will also handle robust alerting workflows so that these incidents get routed to the right team members with the right level of urgency set. Under the timeline section, we can see how this incident was processed, when the countermeasures were run, and who these incidents were routed to and how they reacted and responded. The way that these alerts get routed to your team members is by way of alerting workflows that we call alerting timelines. In your account, you may have one or more alerting workflows so that the right issues get routed to the right team members and the right urgency levels are being communicated. As we drill into a specific workflow, what you'll see is that the timeline has multiple events, and on each event, different trigger actions can take place. This specific workflow is saying 0 seconds into the incident, trigger these 4 different actions. Of those actions, you can use emails, SMS to your mobile phones, automated voice calls, push notifications to your mobile app, ticket creation in common tools like ServiceNow, Jira, and Zendesk, alerts in Microsoft Teams or Slack, and lastly, dynamic on-call scheduling, so that your rotating on-call schedules are being used in the platform so that when an incident occurs, the right person is looked up and the alert is sent to them. In addition to that, you're seeing automated escalations. So should this problem not get resolved by certain team members, the system will automatically escalate to the next level 2 hours later and 5 hours later so that the right members of the team are getting engaged to solve this problem. Utilizing various auto discovery routines and out-of-the-box templates, each and every device, server, and application can be automatically configured without any human intervention. Once that occurs, you'll be presented with an out-of-the-box view or dashboard for that device, server, application. Along the top, we're seeing SLA and availability information. Below that, various metadata that's been auto-discovered and auto-set up for you based on those discovery processes. Once we understand what kind of asset this is, we automatically apply a relevant template to it, which will auto-provision metrics and thresholds for us that are relevant to this profile. We'll see those here under the performance dashboard. Here we're seeing for a FortiSwitch the relevant device metrics and environmental sensors, CPU levels, memory levels, latency of the device, temperature, as well as various sensors around power supply and fan state. Beyond that, we can see each and every network interface that's configured on this device with the configured label, speed, status, and MTUs. We can drill into a specific interface to see performance data, in this case, errors, discarded packets, and bandwidth utilization. Drilling into any of these graphs allows you to see the data at whatever granularity you desire, whether it be more real-time or more historical. Expect the same out-of-the-box experience for configuration and reviewing data for all of your resource types, whether it be a network device, a physical server, a virtual machine, or a cloud-native resource. All of this will be set up for you automatically. Now, as we capture data for all these resource types in the same platform, reporting becomes exponentially more important. And that's where our canned reports can deliver the insights that you need to your team on the schedule of your choice. As you can see here, there are a number of different report types out of the box that give you insights into capacity trends, availability and SLAs, incidents that are occurring, and how long it's taking your team to acknowledge and resolve these problems. These can be set up on a daily, weekly, monthly, or quarterly schedule with the right parameters set so that your team members are getting the right insights delivered to their inbox when they need it most. As you begin to onboard your infrastructure and enable various integrations, other out-of-the-box dashboards will auto-activate for you based on those well-known technology stacks. Beyond those out-of-the-box dashboards, you can create your own custom dashboards. As you can see here, you can represent data in a variety of different formats, whether it be a performance chart, a KPI tile, an incident trending widget, status and availability shown in a table, or metric data shown in bar charts, scorecards, and various other formats. Modifying this dashboard is quick and easy. Hitting Edit enables the canvas, and as I add a new widget, I'm presented with a catalog of over 35 different visualization options to pick from, depending on the type of data I'm trying to present. As I make my selection, I have easy ways of resizing the widget by dragging the corner, as well as selecting various properties and options here to the right, allowing me to customize the look and feel of that widget. When I'm completed, I have the ability to share this dashboard with other users based on different access levels or sharing this private URL with other stakeholders who do not have a login to Panopta. This allows me to share this dashboard in a read-only format with no application navigation and no ability to change anything. It's a great way to involve an external stakeholder. I hope this brief overview gave you a feel for the range of functionality within Panopta and how it can allow you to consolidate all aspects of your IT operations management into a single platform. Thanks for watching.